we have finished the motor and the circuit breaker control. Let's move on to the railing. The railing goes to page 18, F1 and P1. All right, I'll go to page 18. Here it is. This is page 18. Here's F1 and here's P1. Page 18, here's one, and here's what B1, this is the plus R, and this is the minus R. Who is this engineer Rashad? This is the BCPU, the B control and protection unit. So what is drawn inside, engineer Rashad? This is the binary input. What does binary input mean, Rashad? The binary input, engineers, is as I have drawn it for you here. The same binary input, this binary input is an entry to the relay, something that enters the relay to provide it with information. Whether this information is used inside the relay to build logic, like for interlocking, or this information might make it light up the indicator, or I might tell it to send this information to the SAS or the SCADA, depending on the internal programming that I will do inside the system. Inside my relay, okay, what is it exactly? Well, engineer Rashad, I didn't understand you. You have the relay terminals, like terminal E7 and E8, for example. Okay, you connect the negative to E8, and if E7 receives a positive, what happens? There's a diode here internally called an optocoupler. It's not your concern. You don't need to focus on it. It's not important at all. The important thing is that when this diode operates, it receives positive and negative. It emits light, which is what triggers the base current for the transistor inside. Okay. Okay. It triggers the base current for the transistor. Then this transistor operates and sends a signal to a microcontroller inside with 5 volts. The important thing is, regardless, the device understands that there is some information coming to it. So what does this information mean? It depends on how you will program this information. What does this mean? I can take this information and send it to an engineer. No problem. The engineer told me I have to go. Sure, engineer, although I don't like to interrupt. Or for you to interrupt yourself during the lecture to get the maximum benefit. But if you have urgent circumstances, go ahead. If you don't have urgent circumstances, please bear with me for 5 or 10 minutes at most, and then I'll open the floor for questions. You might, use the professions, okay, depending on how I will use this information. I can use this information to create an interlock, for example, by saying that this information means that the breaker spring, for instance, is not charged. So I create logic within my relay to tell it not to close the breaker as long as you have this information. This information means that the spring is not charged. Okay, I am the one who directs what this information means. I can send this information to the people sitting in the SAS or in the SCADA, and there they can program it. If this first piece of information that is present here is received by the relay, it writes a text saying what this information means. Let's bring not charged. Okay, so this information must truly come from the source of let's bring not charged. How does this happen? You connect a negative to the binary input. This binary input means 1 or 0, meaning it is either present or not present. And you provide it with the positive through a specific method. For example, in our case here, the circuit breaker is on, meaning the circuit breaker is working. So when the circuit breaker is on, the contact closes, connecting the positive here. This gives you the information that your breaker is on. All right, very good. So we agreed that the motor of the breaker is depicted in a state where the spring is charged. The MCB, the auxiliary relay, the contactor, and the lockout relay are all in a de-energized state. And the breaker is depicted in a test position and is shown as open. All right. That's why you'll find that this contact, which carries the state of the breaker as open, normal, close, and this contact is normally what? Normally open. So when the breaker closes, this one closes and this one opens for you. So this gives an on signal, and if the breaker opens, this one goes back to close and giving an off signal for the breaker, and this one loses the breaker information. And so on, anything connected to the PCB. So what should be connected to the PCB? The PCB, which is the protection and control unit, should have digital signals connected to it. These digital signals can be used as interlocking circuits, can be used for status, or can be used as alarms. What does this mean? Patience? Patience first. The PCPU is the place of the control panel, right? The control panel used to be drawn in front of the single line diagram, and you would know if the breaker is closed, open, rack in, rack out, whatever, right or wrong. You told me, right? Okay, now for me here. For me here, I don't know now if the PCB is supposed to be the place of the control panel, right or wrong. You told me right, so I am supposed to draw on the screen, as I told you, the single line diagram. So through the single line diagram, I need to look at the breaker to know if it's closed, open, rack in, rack out, if my spring is charged or not, right or wrong, right? So we call this the status. Similarly, for the earth switch, right? Right. The second thing, for example, a circuit like the motor we are charging with, wasn't there something here called DC supervision? You told me yes. So the DC supervision, when it sees that the DC is cut off, isn't it supposed to give me an alarm? Yes. So I should find it here giving me the alarm because it used to send this alarm to the control room. And from there, it would be sent to the SCADA. So now the PCPU is supposed to be in place of the control room, and it should receive a set of alarms, right? Right? All right. The third thing is that it should receive a set of statuses to create an internal circuit for opening or closing. So when I come to close it, I should tell it not to close because the spring is not charged, or the gas pressure is low, or the breaker is not in the trip position or trip out, or for example, the protection is not reset. You might say, oh, all the things you mentioned are present here in the wiring. Here are the requirements of SEC, Aramco, and others. The same thing you did here with the wiring is like unknown variables inside the PLC itself. Even though the PLC is supposed to be used to reduce this wiring process and save us effort out, but as a precaution, I am doing duplication. What does duplication mean? It means that the same thing I did with the wiring, I will do inside the PLC. That's why engineers, you will find here the circuit breaker on and off state. The circuit breaker test state or service state, you have the spring charged or not, whether it's charged or not. The same applies to the RS switch when we talk about it tomorrow, whether it's on or off. All right, and now how does the BCU know whether it will be closed through it or not, right? But you told me in the local, emergency, and remote modes, right? Am I wrong? So it must receive the off, emergency, and local remote modes so that when it's in emergency or off mode, it indicates that the control is not from it. And when it's in local mode, it allows the internal logic to verify. And when someone presses close, it issues the closing command. And if it's in remote mode, and when an event occurs where you press close, it will send you a message saying you are not authorized, meaning you are not allowed to close from my side because the relay is in remote mode. What does that mean? It must be received from the SAS. Additionally, engineer, there is a set of alarms regardless of the type of alarms, such as DC MCB off, meaning any type of my MCBs is off. What does off mean? It means someone has turned it off. Okay, here you are using contact normally close, as you can see. This is contact normally close, but this is the first time I have seen this contact. Its name is contact. What is its name? Its name is changeover contact. Its name is changeover contact change. What does this contact mean? Engineer. It means it's 2 in 1. It means normal open and normal close. One terminal here is common, and you have this terminal with terminal 95, for example, with 96 as normal close, and 95 with 98 as normal open. So if it changes position, 95 with 98 closes, and 95 with 96 becomes open. Okay, what is this drawn as? Drawn in what position? The MCB. So what is the normal position of the MCB in the drawing? So if the MCBs of the DC or any you have, or any of them are off, they are all here in parallel. So the normal state is that if your circuit is working, all of them, right? So if they are all on, then this contact is disconnected, and this one 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 is disconnected. If any of them trips, its contact returns to the normal position, normal close, which is normal close when the MCB is off. The close is when the MCB is off. Therefore, if the MCB is on, all these contacts are open. If one of them is off, the contact returns to the normal close position, connecting the DC here to this input, triggering an alarm immediately, and sending an alarm to the system. Send to what? To the system. To the substation automation system, telling it there's an issue in one of the DC circuits. It doesn't need to specify which circuit. When you check, you'll see which MCB is off. And how do you know the problem is with the MCB and not the wiring? because this comes from context from the MCB, from the miniature circuit breaker. The alarm that was triggered is called the DC MCBs off, meaning one of the MCBs responsible for the DC circuit is in what state? It's in the off state, and so on for any group or any group that enters the relay. Of course, here you had your circuit, and then as you can see, it directed you to which page? It directed you to page 19, which is this page. So it continued here with your signals, and then it came with you to this page where we saw the topic. And the topic, in addition to the fact that it worked here for the power. Yes. A meter, if you have a power meter in your cell, and here's the power supply for the relay itself. The relay itself, and here at the end, you have a DC supervision. Oh, this is supervision. Yes, this is supervision. Okay, and how do I connect this supervision? This supervision is on the relay itself. Well, if the relay itself fails, it is supposed to trigger the alarm or connect it to the SCADA system. How do we supervise its circuit? If you look at this, which is mentioned on page 20, this is 8, which is here, which is F13, okay? You will find here, look, there is something connected here, going to something called common allure on page 27, B7. If you go here to page 27, here is page 27, this is 26, 7. If you go here to page 27, here is page 27, this is 26. This is page 27, and it says here, CAM B7, this is the contact. This contact, indeed, engineer, is supposed to monitor the relay's circuit. So if the relay is off, it should go to the relay so that the relay can take the signal and send it to the SAS. All right, the relay itself is off. How does it understand? Yes, in this situation, when you have it on the relay itself, which is originally the one that has it, and it's the one that has it, and it's the one that sends the alarms to the SCADA. In this case, what do? You take this counter, not send it to the relay, and what do? You send it here to a panel in your control room. Oh, sorry, it's called the protection room. It's called the common alarm panel. What's it called? The common alarm panel, which is the unified alarm cell that contains things that couldn't be transferred via the PCU. Among them is the DC supervision on the protection relay circuit. Okay, I will find next to it a relay, and we will find the difference between this and that. Yes, this monitors the positive and negative on the circuit. So if the positive and negative are cut anywhere in the circuit, it can detect it and send you an alarm. So what is the status of this contact? Normally closed. When is it normally closed? Engineers. When is it normally closed? Engineer Rashad. Normally closed is attributed to the auxiliary. Its natural state is the state of the auxiliary. How is it depicted in the drawing? It is de-energized. So as long as it is de-energized, this contact is closed and sends you an alarm. This means if everything is fine and the auxiliary is working, this contact is open. When there is a DC fault, this contact closes and sends you an alarm. All right, you told me all right. At the same time, engineer, your relay circuit might be perfectly fine with no issues at all. The entire circuit is intact. However, internally, the relay's power supply circuit might have a problem, or its cards might have an issue. Here, engineer, we have something else that we call the main relay field. Focus with me on the terms I'm going to write down for you here. It's called IRF, which stands for internal relay fault, meaning an issue within the relay itself. It's also referred to as a watchdog, which is like a guard dog that watches over something, or they call it live status, meaning whether it is active or not, or they refer to it as the healthy status. Also, any of these terms, in the end, lead you to the same idea. Here, once any device, like mobile phones, has supervision internally, it monitors itself on the input cards, output cards, microcontroller, software, and internal power supply circuit. Why? Because now everything inside consists of microcontrollers and components working internally. So, if an internal disconnection occurs, how would it understand that the relay might not be functioning properly? Here, internally, there is supervision on its circuit. In this case, as long as the relay status is depicted in the drawing, whether it is operational or not, Whether it is operational or not, it is certainly in a non-operational state. Why? Because the MCB is depicted in the drawing as being non-operational. So, as long as the MCB is open, how can the relay be operational? When it is not receiving a supply. As long as the relay is not operational, this contact remains closed, as you can see here. As soon as you switch on the MCB and the relay becomes operational and healthy with no issues, this contact opens. As soon as an internal fault occurs within the relay itself, in one of the internal circuits, whether it is a software or hardware alarm, we call it a software or hardware alarm. Do we call it, or should we call it soft? It comes back, no heat, it comes back, and it comes back. In this case, what happens in this situation? In this case, if you want to send the signal from the common alarm band, don't forget. So welcome to a new phase. Welcome to a new phase.